Okay, so now we are on to 3.6. This is polynomials of the form ax squared plus bx plus c. So we know from 3.5 how to solve and factor trinomials with a coefficient of positive 1. So where a is positive 1. But what happens if we can't make that positive 1? Okay, we need to learn a new method. Now, here we should know and understand how to expand these. Okay, so please practice on how to expand these before moving forward. If you do not know how to expand them, you need to go back and rework them. So I'll quickly show you the answer to this one. So this will be 3d times 4d, which gives me 12d squared. 3d times 2, which gives me positive 6d. 4 times 4d, which gives me 16d squared, or sorry, not d squared, just 16d. 4 times 2, which gives me 8. Then I combine my variables here, or my like terms. My like terms are the numbers with the variable that have the same exponents. So this would be 12d squared plus 22d plus 8. So there's my expanded form of these two binomials multiplying each other. So please give this one a shot on your own, okay? The answer you should get is 10e squared. Then I will get 20e, and then 6e, and then 12. So you should get 10e squared plus 26e plus 12. So you should go through that and make sure you can get that on your own before moving forward. If you cannot, you need to come in and ask questions. Okay, so just recall what a leading coefficient is. A leading coefficient is that number that's attached to the variable with the largest exponent. So if I had something that looked like 4x plus 8x squared minus 1, this would be your leading coefficient. Okay, because it is attached to the variable with the largest exponent. If I had something that looked like this, x to the power of 4, let's say negative x to the power of 4 plus 3x squared minus 1. This is your variable with the largest exponent, so that makes it this number here. And remember, if there's no number in front, you can assume it's 1. This has a leading coefficient of negative 1. Okay, so far we know how to factor trinomials where our leading coefficient is just positive 1. Okay, but what happens if we can't make it positive 1? So we can't factor anything out, it just has to be that number. You have to factor by decomposition. Okay, so it's kind of like PSA but with a tiny little twist. The twist is when you do your PSA and you find the number that's your product, this number is going to be your leading coefficient times your constant. Okay, and then you have to do a little bit of extra as you actually factor it out. So here, let's perform factoring by decomposition on this trinomial. So recognize I can't factor 4 out because 4 doesn't divide 9 very well. So what will be my product here? Remember, my product is my leading coefficient times my constant. So here, my leading coefficient is 4, my constant is 9, so it'll be 4 times 9. And what does that give me? Let's just quickly check here. 4 times 9, that gives me 36. So here my product's going to be 36. My sum will still be 20 here. Okay, so it's still the number that is found with your variable with just a exponent of 1. So this will be 20. And now it's like performing regularly. So to start answering this question, sorry, I had to do that. To start answering this question, what two numbers multiply to 36 and what same two numbers add to 20? Okay, so here let's kind of list out the things we know about 36. Okay, so 36, that has a positive and negative 1, okay, factor. Positive and negative 2, because 2 times 18, I believe, is 36. And then there's also 6 involved, so 6 times 6, and then 36 times 1. So here, I'm kind of already looking at 18 and 2 here. I'm looking at 18 and 2 because I know that 18 plus 2 gives me 20. So let's try and do a few variations of signs here. So let's just try 2 times 18 to begin with. 2 times 18 gives me 36, as we said. And then 2 plus 18 gives me 20. So it looks like there's my A value and my B value. So A equals 36, or sorry, A equals 2, and then B could equal 18. Okay, so recognize it is not as simple as just doing H plus 2 and then H plus 18. That's completely wrong. Okay, that's not factoring by decomposition. You can only do that little method if your leading coefficient is in fact positive 1. Okay, so this is where we have to factor by decomposition. So what we're going to do is I'm going to rewrite our example here. Okay, and now what I'm going to do is I'm going to replace 2 and 18 in for 20h. So what does that look like? It says what I'm going to do. I'm going to do 4h squared. Now I'm going to do plus 2h plus 18h plus 9. Okay, so I have 20h here, and I've now replaced it with 2h plus 18h. Okay, and those are my answers here. Now, this is kind of the tough part to understand. I'm going to factor out everything I can in my front two terms, and then I'm going to factor out everything I can in my next two terms. Okay, so what can I factor out of 4h squared plus 2h? Well, I can factor a 2h out. 4 and 2 are divisible by 2, and each one has a single h. So here I'm going to factor out 2h. Now, remember what you're doing when you're factoring out. You're dividing this by everything in here. So 4h squared divided by 2h. That becomes 2, and then h squared divided by h gives me 1. Or sorry, h. So what I'm going to be left here is 2h, and then 2h divided by 2h, well, that simply gives me 1. Okay, 2 divided by 2 is 1, h divided by h is 1. So this will be plus 1. Now my next step is now I have kind of a goal here. What can I factor out of this in order to get to 2h plus 1? Well, I can factor out a 9, okay? So I'm going to do maybe in a different color here so we can visually see what's going on. Plus 9, and I'm factoring out a 9. So 18h divided by 9. 18 divided by 9 gives me 2, and that's 2h. So this will be 2h, and then 9 divided by 9, okay? 9 divided by 9, well, that's going to give me 1, so plus 1. Now, here we can see we have gotten to 2h plus 1 and 2h plus 1 in both sides. So what's going to happen is that's going to factor out. Okay, I can factor those out and do 2h plus 1. And I factored this guy out. And I've taken 2h plus 1 out of each individual term. And I'm left with 2h plus 9 in the other term. 2h plus 9. Okay, so here let's do some highlighting to visually see. So you can see that I've taken this out and I'm left with, let's maybe use green here. And I'm left with, oh, that's not what I wanted to do. I'm left with 2h and 9, so that's where I got that. Okay, and that we were able to factor by decomposition this trinomial. Okay, So practice, practice, practice. I would suggest even pausing the video and trying to do this on your own, kind of referencing what we did here. Okay, so let's move on to the next one here. So 6kx minus 11x minus 35. So this one looks pretty tough, okay, but I think we can do it. So we're going to PSA this. Now remember, I can't factor 6 out of any of these very nicely. Okay, so since I can't factor 6 out super nicely, the first thing I'm going to do is figure out what my product has to be. Remember, my product is found by multiplying my leading coefficient by my constant. So 6 times negative 35. That's definitely a calculator question there. Let's pull out the calculator here. So 6 times negative 35. That gives me negative 210. Oh. Okay, so sometimes your values are pretty big. So my product has to be negative 210. And that's some number times some number. And then my sum will be negative 11, right? The middle value there. So that will be the same two numbers adding together. Okay, so I'm definitely going to have to figure out some of the factors of negative 210. So I already know plus and minus 1 is involved. You can divide to negative 210, dividing by 2. So that will give me plus or minus, so this will be positive negative 2, and then positive negative 105. Okay, what else can we divide 210 by? I know I can divide by negative 210 by 5. So 5 won't really help, but I know that 5 times 42, negative 5 times 42 equals negative 210. Okay, negative 210 dividing 10, that gives me negative 21. Okay, so 10 times negative 21 equals 210. Now I'm going to stop there and kind of analyze what I have. I know that this isn't super helpful to us because like any variation of 42 minus 5, like that's not going to get us near a negative 11 at all. Okay, but looking at this 10 and 21, I can already tell there's kind of a difference of 11 somewhere in there, right? So let's kind of play around with this 10 and 21 thing. So I know that 10 times negative 21 gives me 210. Let's try and do 10 plus negative 21. 10 plus negative 21. And that's going to give me negative 11. So that is what we're looking for here. We were looking for two numbers that multiply to negative 210 and the same two numbers that add to negative 11. So here, this can be shown as 10 and negative 21, and then 10 and negative 21. So here my A and my B values, remember that's just what I represent them as. This will be 10 and negative 21. Okay, so we figured that out, which is great. So we can, again, what do we do here? We replace these numbers with our coefficients with the variable that has the exponent of 1. So I'm going to replace 10 minus 21 with negative 11. So let's write that down here. So 6k squared minus 11k minus 35. I'm going to replace that with 6k squared, and then I'm going to make it plus 10k minus 21k minus 35. So I've replaced these two numbers here and here. And now we can try and start factoring things out. So remember, your goal is to factor the first two terms and then factor out the last two terms. So let's focus on our yellow terms here. So what does 6k and 10k have in common? Well, they have a k involved, and then they also can be factored out by 2. So 2k divided by 6k squared, Okay, so remember I'm taking 6k squared and I'm dividing it by 2k. 6 divided by 2 gives me 3. And then 1k cancels out and you're left with k on top. So this will be 3k. You probably want to write what we just did here, even lower, okay? And then we're going to do 10k divided by 2k. 10 divided by 2 gives me positive 5. And then k divided by k cancels out. So what I did there is I did 10k divided by 2k. My k's cancel out, and then 10 divided by 2 gives me 5. So that's where we got this number from. And then we can bracket. Now, remember, in order for this to work, we need to factor out the proper number here to get these two binomials to be the exact same. So something I'm going to recognize here is both my numbers are negatives. So I know I need to divide a negative out because both these numbers are positive in the other binomial. So I'm going to subtract something. Now, how do I make 21 to turn into 3? I divide it by 7. How do I make 35 divided by 5, or how do I make 35 turn into 5? I also divide by 7. So here I'm going to factor out a negative 7. Okay, and then I'm going to get negative 21k divided by negative 7, and that's going to give you positive 3k, right? Negative 21 divided by negative 7 gives you positive 3, and your k is left over. So this will be positive 3. Then I'm also going to do negative 35 dividing negative 7. And that's just going to leave you with positive 5. Okay, two negatives make a positive. So here's positive 5. Now we've gotten to where we want, right? We have our two binomials that are the exact same, and then you have 2k minus 7. So I'm going to factor out these two similar binomials, and I'm going to get 3k plus 5, and then I'm going to have 2k minus 7 left over. 2k minus 7 is left over. And there is your solution in your factored form for this trinomial. Okay, so you definitely, hopefully you're seeing like, wow, I definitely need to practice a ton in order to get this down. Okay, but again, is it crucial? Absolutely, to understand. Okay, let's move on, and maybe we can do these last two examples here, because the more examples, the better with this kind of stuff. So in this next example, sometimes it's useful to look at if you can factor something out before you even begin. So here, like, the best idea is to see if you can factor out your leading coefficient, of course, but here I can't because 9 and 6 are not divisible. Neither is 21 and 6. So what can I do then? Well, notice that each number is divisible by 3. So before I even start, I'm going to factor out a 3 here. Okay, and then I'm going to do 6 divided by 3. So I'm going to be left with 2x squared minus 7x plus 3. So remember, where did I get all these numbers? 6 divided by 3 gives me 2. Negative 21 divided by 3 gives me negative 7. 9 divided by 3 gives me 3. Okay. So what we did is essentially divided each thing by 3 so we could factor it out. Now this makes our life a little easier because we're just going to mainly focus on this and factor this. Note, if we didn't factor this 3 out, you could still get a factored solution. You're just dealing with bigger numbers. But I want to make these numbers smaller to deal with. Now I'm going to still have to PSA my answer here. So two numbers that multiply to what number? Well, here it'll be my leading coefficient multiplied my constant, so 2 times 3. Okay, 2 times 3 gives me 6. So this is going to be my product. So here, this will be 6. 2 times 3 gives me 6. These same two numbers need to add to negative 7, right? It's always that middle coefficient that is attached to the variable with an exponent of 1. So this will be negative 7 here. Now, what are these answers here? What is A and B in this case? Well, I know that my product has to be 6. So what are the numbers that multiply to 6? There is 2 times 3, which gives me 6. there is 1 times 6, which gives me 6. Now, 2 and 3 don't really work very well, okay? Because 2 plus 3 gives me 5. 2 minus 3 gives me negative 1. Negative 2 plus negative 3 gives me negative 1. So on and so forth. But here, I notice that my sum has to be negative 7. That's only 1 off from 6. So I know that 1 times 6 gives me 6. 1 plus 6 gives me 7. But recognize this is the incorrect value. Okay, it's not negative 7. This is giving positive 7 when we want negative 7. So what I'm going to do is I'm going to put some different signs on here. So negative 1 times negative 6. 2 negatives give me a positive, so that still gives me positive 6. Negative 1 plus negative 6, well, that gives me negative 7. So my solution is found here. If I have negative 1 times negative 6 and negative 1 plus negative 6, that gives me the solutions I'm looking for. So my one value is negative 1, my other value is negative 6. Now remember, we can't simply just plug it in like we did in, I think, 3.3. Okay, that's not going to work because we don't have a leading coefficient of positive 1. So what I'm going to do is I'm going to rewrite what we have here. So 3 times 2x squared minus 7x plus 3. And remember, now we have to factor by decomposition. So I'm going to replace negative 7x with my two answers here. So remember, I'm not going to forget my 3, and it'll be 2x squared minus x minus 6x plus 3. And from here, I'm going to factor by decomposition. So I'm going to focus on my first two terms, and then I will focus on my second two terms. Okay, so these first two terms, what can I factor out? Well, I can factor out an x. So here, I'm going to utilize my square brackets because right now I have to remember that 3 is continuously following along. So I'm going to factor out an x here. And when I factor out an x out of this, I am left with 2x minus 1. Okay, how did I get that? Remember, when you factor something out, okay, you divide out the thing you're factoring by every term. So here it'll be 2x squared divided by 2. Divided by x, which leaves you with 1x on the top and 2 is still there. So that's where we get 2x. We factor out an x, negative x divided by x gives me negative 1. Okay, so now we are going to focus on the green terms, the last two terms. And remember, my goal here in factoring by decomposition is what can I factor out here to get this term as well. So here I want negative 6x to turn into positive 2x. Well, that probably means I'm going to have to divide a negative 3. I want 3 to turn into negative 1. Well, that means I have to divide by negative 3 as well. So it looks like we're factoring out a negative 3. Okay, sorry. So negative 6x plus 3. And we're dividing each term by negative 3 in this case. And that will give me negative 6 divided by negative 3 gives me positive 2x. Positive 3 divided by negative 3 gives me negative 1. So I'm left inside here with 2x minus 1, which was what our goal was. Okay. So at this point, it's simply just finishing off our factoring. So we can just move this down quickly. So what's going to happen here is recognize I have 2x minus 1 in common in both terms, right? This here represents a whole term. This here represents a whole nother term. Okay, so what I'm going to do is I'm going to factor out 2x minus 1 by both terms. And remember that 3 is simply just multiplying this whole thing. So I'm going to take out 2x minus 1. And when I take out 2x minus 1, what's left in each other term? Well, x minus 3. So this will be x minus 3. And there is my factored form of the trinomial above. 6x squared minus 21x plus 9. So this is the factored form. If you expanded this thing, you should get the above solution. Okay. Let's do one more example, and then you can practice on your own. So here we have 3s squared minus 13s minus 10. So clearly we cannot divide 3 out to get this to be a positive 1. So it looks like we're going to have to factor by decomposition again. So remember, my product is two numbers that multiply to what? Well, this time we have to do 3, my leading coefficient, multiplied by my constant, which is negative 10. So 3 times negative 10 gives me negative 30. So that would be negative 30 here. And then the same two numbers need to add to our middle value, which is negative 13. Okay, so remember, what are my factors of negative 30? So what multiplies to negative 30? Well, I know that 30 times 1, negative 30 times 1 gives me negative 30. But this isn't going to be super helpful because recognize there's really no way to add any variation, putting the signs in different spots to get to all the way to 13. Okay, this will just be a 1 difference. So clearly 30 and 1 won't work. 30 is also divisible by 5. Okay, so I know that 6 times negative 5 equals negative 30. Okay, so this might possibly work. Let's try 6 plus negative 5. Well, that doesn't work. That gives me positive 1. So 6 and negative 5 won't work. What if we switch the signs? Negative 6 times positive 5 gives me negative 30. So negative 6 plus 5 will give me negative 1. So that doesn't work either. Okay. How about if we try, well, we could do a few more variations, like we could do negative 6 times negative 5, but that gives me positive 30. So that's not actually going to work because we need it to be negative 30 as our product. So negative 6 and negative 5 are already out of the solution here. One other solution is possibly negative 30, or sorry, negative 3 times 10, which gives me negative 30. So this can possibly work because 3 plus 10 is 13. So let's try and see what happens here. Negative 3 plus 10, well, that gives me positive 7. So that won't work. Let's switch the signs there. 3 times negative 10 gives me negative 30. 3 plus negative 10, well, that won't work either because that's just going to give me negative 7. Okay, so we're trying to find negative 13, right? I have one other idea. I know that 15 times negative 2 gives me negative 30. 15 plus negative 2, well, that gives me positive 13. So this is positive 13. I want negative 13. So if I just simply switch the signs here, it should work. Let's do negative 15 times 2. That gives me negative 30. Negative 15 plus 2 gives me negative 13. So there's my product and there's my sum. So it looks like it'll be negative 15 and 2 and negative 15 and 2. Okay, so my answers here will be negative 15 and 2. Now remember, I can't simply just do it like we did in 3.3 because this is a little bit more difficult. We have to factor by decomp. So what we're going to do is we're going to replace negative 13s with negative 15s and 2s. So here I'm going to write this out as 3s squared minus 15s plus 2s minus 10. Okay, and now again, let's just make sure we all understand that this is an s and this is an s. So 15s, 2s. Okay, try and write that out as clearly as possible here. Now remember, first thing is focus on the first two terms, and then put your attention to the next two terms. So let's factor out what we can factor out in the first two terms. Well, 3 and 15 are both divisible by 3, and they both have a s in them. So I'm going to factor out that s. So 3s squared divided by 3s, well, 3 divided by 3 gives me 1. S squared divided by s gives me a single s. So this represents s, 1s. So here, this will be 1s And then negative 15s divided by 3s. Negative 15 divided by 3 gives me negative 5, and then the s's cancel out. So you're just left with negative 5 here. Okay. Now, we're focusing on the next two terms. Remember, our goal is, what can I factor out here to get s minus 5? Well, if I factor out a 2, I will be left with 2s divided by 2, which gives me just s. And then negative 10 divided by 2 gives me negative 5. So it looks like if I factor out a positive, if I factor out a positive 2, I will get s minus 5. Okay, and remember, these are s's. S was probably a poor variable to choose, but that's okay. So I factored out a 2 here, and I'm left with s minus 5. And then recognize we have similar terms. So we can factor out s minus 5, and what we're going to be left with is s minus 5 multiplying 3s plus 2. And there is my factored solution. Okay? And remember, you could expand this and check your answer, which would be a good idea. But there is your final solution. So you guys really, really need to practice this. I would honestly suggest just going back and retrying each question here before trying it out on your own and getting to the solution without even having to reference your notes here. Now, please go check your understanding with AFL 3.6. And if you have any questions, you definitely need to come in and ask questions, because this stuff can get pretty confusing if you're doing it all on your own.